Hi everyone! In this video, we will understand the process of hypothesis testing. Dr. Smith is conducting a study on the average blood pressure levels of patients who visit her clinic. According to the National Health Data, the average systolic blood pressure for adults is 120 millimeters of mercury. However, Dr. Smith believes that the average in her clinic is higher due to the stressful urban environment where her clinic is located. Describe the process that Dr. Smith would go through to test her hypothesis, defining key terms along the way. The first thing we need for a hypothesis test are the hypotheses. We need to know what the original claim is and the alternative, what we're going to be testing against the accepted norm. So the first thing we need is the null hypothesis and the alternative hypothesis. The null hypothesis is the accepted norm of the day. So right now, the accepted norm is that the adults have a blood pressure of 120 millimeters of mercury. Dr. Smith wants to test her claim that at her clinic, it's higher, the blood pressure is higher on average due to the stressful environment where her clinic is located. So the alternative is that the average blood pressure is greater than the accepted norm of 120 millimeters of mercury. The second step that Dr. Smith will take is to choose a significance level. Let's go ahead and choose a significance level for Dr. Smith. Let's do 0.05. The significance level is our tolerance for whether the sample parameter is different enough outside of the norm from what we expect. The third step for Dr. Smith is to collect data from a random sample of patients at her clinic. After she collects her data, she calculates her test statistic from her sample. This will either be a z-score or a t-statistic. Next, Dr. Smith will either find the critical value, which gives us a cutoff for a rejection region, or we'll find the probability or the area under the curve for the z-score from the test statistic. This is called the p-value. The last step for Dr. Smith will be to compare her p-value with her significance level, or to see if her test statistic falls within the rejection region. Because we are doing a hypothesis to compare against the norm or the average, we can look at a normal curve to help us visualize what we are finding with our hypothesis test. The normal or the average is right in the center. Dr. Smith is claiming that the average at her clinic is a higher blood pressure than the average for the population. So it's going to be up here in the higher region. We chose a significance level of 0.05, and we have a critical value that will give us a cutoff so that we have a defining line of where we would consider the normal blood pressure versus something that's going to be more extreme for her clinic, for the sample that she chose. If Dr. Smith's test statistic fell within the normal range, then her claim that the average blood pressure at her clinic is higher doesn't seem very likely because it is very close to the population average. However, if she has a test statistic that ends up being quite a bit higher than the average up here, it would fall within the rejection region, meaning it's very unlikely that Dr. Smith could pick a random sample at her clinic and have it be so high above the average, so it would be statistically significant that it would be abnormal or higher due to the stress of the urban environment. So we can say if the p-value compared to alpha is larger than alpha, then it would be within the normal region. This is the fail to reject the claim that it is outside of the norm, in this case higher, and it's falling within the norm, then we fail to reject the null that it is the norm. So we fail to reject the null. However, if our p-value ends up being less than alpha and it lands inside this very small area over here beyond the rejection region, then we will reject the null because there is significant evidence to support the alternative hypothesis. And now we're all done.